So here, this time we are going to start a different new topic from continuing in the introductory contents of this Python into Python programming. Here, in lecture number 3, we are introducing control structures, what are known as control structures, and under control structures, one of the structures, which is we call the conditional structure or the if-else structure. Of course, this is divided into several parts, as you can see in the topical outline. So let's proceed. And as usual, this lecture also is divided into several parts, which you will be able to view as different recordings as well. Right, so let's look at the... So here's the references for this lecture session in lecture in the notes. You will find these parts covered in chapters 2 and 3, and this is basically continuing from our previous discussion again. And additionally, we provide, as usual, we are giving you these references if you want to know further details on Python documentation of various types that we have shown before. All right, and also for the code examples that we have given in the notes, if you want to just look at them, how they execute, for convenience, you can go to Jupyter Notebooks to see how they execute as well. All right. Right. So let's look at, let's start with the topics for this discussion. First, let's look at what these control structures are. So there's something called a control flow. Before we go to control structures, there's something called control flow. So what is the control flow? What is control flow? Or we also say flow of control. What do we mean by that in a program? First of all, what do we mean by control? And then we talk about control flow. So control is basically now a program in execution. A program in execution, you can say in a computer, a program consists of several instructions, and as the program gets executed, what we see is that programs are executed in an instruction by instruction kind of manner, right? So when you talk about a particular program in execution, at any given moment, there is one instruction getting executed, right? At any given moment, you can basically say it happens one by one. So at any given moment, there's one particular instruction being executed. Especially we are talking about standard, what we call serial computation of serial computers, which means the execution happens sequentially, one instruction at a time. Of course, things will be different when if you're talking about parallel computers, where at any given moment, maybe there are many or simultaneously many instructions being executed on different processors or different cores. But here, basically, we are assuming a single processor. And when you talk about a program in execution, at any given moment, there's one instruction being executed. And we can say that that instruction is in control, right? Basically, the CPU is carrying out that particular instruction, right? What is the task to be done? So you can say that instruction is in control of the CPU and the computer. So whatever happens is basically what was dictated by that particular instruction. So that's basically, instruction is in control, right? What happens, so what is being done. Now, of course, when many instructions are there in the program and instructions are executed one after the other, so then we can talk about this control that we talked about is flowing from one instruction to another. So that's a flow of control as the instructions are getting executed. But sometimes it's important to basically to also indicate, so that the term control flow or flow of control is basically means that basically that the control is flowing from one instruction to another, right, and so forth as program gets executed. But usually the term control flow or flow of control is used to refer to the movement of flow, the control from one instruction to another in a little bit more detail, to refer to the order in which the individual statements are executed. Or in other words, it indicates, right, the flow of control also indicates the order in which instructions get executed also, because as we say, each instruction is in control when it gets executed. So when you look at the order in which the instructions get executed, then you can refer to that, okay, the flow is controlled also happens in that manner. So in other words, as the flow of control or control flow means that the order in which the individual statements or instructions are getting executed. Here, the term statements I'm using fairly freely here you may have noted that I use the term instructions because at the lowest level, when it comes to the central processing unit or CPU, it executes instructions that basically which are basically in, we say, machine code, right? Of course, at the fairly high level, we may refer to things in a high-level language statements, although they are not like one-to-one. In a high-level manner, in a let's say even an algorithm, if you talk about an algorithm given in a pseudocode or flowchart, a particular statement or one single line may be referred to a statement, whereas if you consider the machine level, how even a high-level language statement, when it gets translated, might get converted into several machine-level instructions. So either way, this description is still valid. You can consider this in a high-level manner with respect to high-level language statements. In the flow of control basically happens from one statement to another. In that manner, that's no harm in assuming that, because in the high-level programs, let's say in a C or Python program, for example, you can consider the statements are executed one by one, and at any given moment, that one statement is in control. That's not a completely wrong thing to consider. Basically, if you assume that the statements gets executed one by one, right? If that is the way we assume, it's enough. It's simple enough, or maybe not basically invalid to assume that way for the sake of understanding that in a high-level language program, at any given moment, a statement is in control, right? But when it comes to the machine level, the actual execution time, it's we know that what is being executed are machine learning instructions. So at that point, at that level, we can talk about instructions being in control and the order in which the individual instructions are being executed. But for us, now that we are talking mainly about Python language and fairly a little bit higher level, no harm in understanding these as the order in which individual statements of a program has been executed. All right. Okay, so let's proceed. So far in our examples, we have seen sequential control, or you can also say serial execution. That means, what is that? It is actually the default or the standard way things get executed. It means statements are getting executed from top to bottom as they appear in the program. So the first one gets executed first. Then if there's no other change, the second one gets executed, and the third one, and the fourth one, like that it goes. Usually we list these statements like a top to bottom manner, right? Starting in first one comes first, then below that we have the second one, and below that we have the third one, and so forth. So it's basically in the top to bottom manner, because that's what we humans like to list down things. So we normally don't list things bottom to top, right? So it's basically a top-down manner. So that's what we call sequential control flow. Instructions or statements getting executed from top to bottom as they appear in the program. This is when there is no change happening to the flow of control. If there's no change, simply goes from top to bottom one by one, right? As they appear, right? As they are listed. But actually, this can change. This, in fact, to be useful, to do any useful computation with computers, this sequential control flow is not really useful much, because then you are basically limited to do certain things, kinds of things only. But things become more interesting and like more powerful if you can change this control flow in various situations, right? For example, you want to make a decision. We want to do this instruction if a particular condition occurs, or another instruction if that condition doesn't hold, right? And some of the instructions we may want to do multiple number of times, repeatedly. And that's also very interesting. Right? So this kind of, so in such situations, definitely it's going to change the control flow, because the instructions or statements are not getting executed just in top to bottom manner. Sometimes you may want to skip. You will be skipping some statements and go forward and do something else. Or a repetition means after doing some statement, we may go back to some previous one and started doing the same things again, and we may do it several times or many number of times. So these kinds of change of control flow is quite interesting, and will add a lot of power, capability to do very interesting computations. That's indeed what programming actually provides us, right? So let's look at those. So those are the ones here. So there's something called a selection control flow, also known as conditional, then repetition, in other words, loop, and subprogram. So these three additional control flows that we have. So let's look at them. So here we list the sequential one that we are familiar with. Statements are executed from top to bottom, one by one, sequentially in the listed order. Statement I, then the statement I+1, statement I+2, like that. It goes down like that. We have shown the flow chart structure so that it is easy to understand, right? If it is a set of things one after the other in the flow chart, and this is how things will get executed. So when this gets executed, this statement is in control, and then the control passes to this statement, right? And when this gets executed, it is in control of the computer, the CPU, and other things, right? Things as a part of the execution, things happen as this statement wanted, or as this statement directed, right? So that's basically what we mean by the control. So the control is flowing from statement I to I+1, and from I+1 to I+2, right? The control is flowing or flowing. And you can see the flow of control. And then let's look at the selection. The selection here, we come to we show the flow chart equivalent because it's easy to then explain and understand. So we come to a point and we ask a question, or we check a particular condition, right? And the answer is either yes or no. So if the answer is yes, if the condition is true, in other words, we execute something here indicated by block A. So block A means actually a single operation, or even maybe a set of statements. This can be a complicated set of things here. So we just put them as single block. It can be a single statement here, or multiples of them. So that's what we mean by block A. And then go this way and continue this way. That means if the answer for this condition or selection is yes, we simply skipped block B and only execute block A. Or if the answer was no or false, in other words, if you are checking a condition and if this evaluates to equivalently like no, we can say false, then block B will get executed. Again, block B can be a single statement or multiple statements there. And then you go this way. In that situation, block A will get skipped, right? We don't do anything in the block A. So this gives a very nice way of, doing something upon a particular condition, right? You check something and based on that, we can actually do something this or that. So it's a very good ability for computations, right? Because it's a very important thing, useful thing, because at the time of execution, we can look at a particular situation, whether something has happened, something has not happened, or whether some condition is true or false, like that. We can decide, and accordingly, we can do this or that. So this is selection control structure. Then we have the loop or repetition. Here, again, the equivalent flowchart structure is shown. But remember that this is just one type of loop structure. So let's see what happens here. So we come here in the flowchart, we come to a situation where you ask this condition, we check this condition. The decision is okay, whether to loop or not. If the answer is yes, then you go inside some set of actions, maybe a single statement or multiple statements, which we consider as what we call a loop body. Because this yes condition tells us, yes answer tells us, okay, now you got to execute this loop body, this set of statements, one or more statements that are in the loop body needs to be executed. So we do that. After doing that, we go back to previous occasion in the flowchart and come back to this again, check condition. So that's basically what we call a repetition or loop. And you can see loop means it's a closed path here. Go back to somewhere which we were earlier and check this condition. And if the answer is yes again, you repeat once more, you execute the loop body and come back here. So as long as this condition is yes, you do multiple times. Every time you start, you check the condition. If the answer is yes, you execute this body. At some point, if the answer is no, then of course you don't go into the loop body, you simply move forward according to the next one and continue from there. Now, I mentioned that this is one possible loop structure. So there can be other, slightly different, but having still a loop body and a loop condition, slightly different. So what can be such as, can you imagine such a situation, a slight difference here? To understand that, let me ask this question. In this loop structure, is it possible that this loop body will not get executed even once? Again, the question is it possible that this loop body does not get executed even once, at least even once? Yes, it is possible, because the very first time itself, if the answer is no, you come this way, go out without executing this loop body even one time. Right? That is possible. But there can be other loop structure that we can construct, we can show even in the loop, even in the flowchart, right? Like this, let's say, let me draw this thing like this. So let's say we have a particular, say, we do some operation, right? And after that, we check the condition. Let's say ask loop and ask the question. And then if the answer is no, okay, you go down. But if the answer is yes, let's say you go backward and come into a situation like this. What do you think about this? So what is the difference between this, the second one, let's say this is second one, and this is the first one? What is the difference between first and the second? Is there a difference? There should be a difference. What is that? This is that condition that I asked. So let me say, so in this second loop, second control structure, we can consider this as the loop body, because that is the one getting executed again and again as long as this condition is true or condition is yes, right? Because that's loop body gets executed repeatedly. But for the question that I asked earlier for the loop structure 1 here, whether the loop body can get executed, or in other words, let me say it again. In the second loop structure, is it possible that the loop body does not get executed at least once? No, it's not possible, right? The loop body will get executed at least once. It must get executed because you first execute the loop body here, and then after that, only we check the condition, loop condition. So by that time, we have already executed the loop body, right? At least once. So if no, it goes, but it has already executed once, right? If yes, you go back and execute it again and execute again, and it can go on and on. But the difference between 1 and 2 is that in the loop 1, the loop body may not get executed even once, whereas in the second one, the loop body will get executed at least once, right? But this can be sometimes what we want, right? And so in developing computer programs or in writing algorithms, sometimes depending on the situation, you will have to choose the suitable one, appropriate one. Both 1 and 2, you can't say one is right, second is wrong or anything. Both are correct. It depends on what you need, right, for your computation. Right? And in programming languages, there are sometimes both 1 and 2 are supported by various what we call looping constructs, right? So we are actually not going to discuss loop structures in this lecture. We will learn about looping structures next on lecture 4. And but here we'll just introducing the control structures which are applicable to loops also. So I hope you will remember this when you are discussing or when you are studying loops in the or Python loops. How actually Python supports looping, right? Okay, so that's loops in subprogram. Now, what is a subprogram? This is where you call what we call something generically known as subprogram. Actually, subprograms have other names in different contexts. Sometimes in generically, we can call them as subroutine, procedure, function, subprogram, as we have shown here. All these basically means the same thing, right? Subroutine, procedure, function, subprogram. In algorithm descriptions, like in your pseudocode and so forth, you can actually use any of these things generically, right? In some programming languages, so they have their own terminology. For example, in Python, function is used to refer to this subprogram. In C also you have functions in C language. In object-oriented languages like Java, you have functions that are basically defined in terms of the objects, and we call them methods sometimes, right? That's a generic term used. And in languages like Pascal, which is an old language, they had both procedure as well as function. In such a language, procedure was simply doing something, whereas function always returned a value, right? So either way, or whatever. So basically, I hope you get the idea. You will learn about functions or subprograms that Python support, which are functions, in a later lecture again. We are not going to cover that, but just because here is the point where we discuss control structure. So let's just look at from limited to that aspect, right? About the control structure aspect. So what do we mean by this? So we call a subprogram. Now in the Python program, the situation is like when you call the in a Python program, you call the print function. Or the ID function, whatever. So print is a very familiar thing by now for you. So let's say, so that is what happens here when you say, when you call a subprogram, means you are calling the print function. And at that point, what happens actually? So up to that point, maybe whatever your instructions, this was a statement which was here, maybe were in control, we know that, right? So when this was getting executed, this was in control. And after that, when this is getting executed, this is in control. And then the control passes here, and here just a calling of it's like the print, calling the print function. At that point, what happens is, we here with the arrow here, we show how the control passes to the particular subprogram, which means your execution will now go to this print function, right? So that will be a set of instructions which we don't know because we didn't write that code. It is a library, we call it library function. It's a built-in function provided by Python. So it will, inside the print function, there may be some statements there, those things. So as we shown here, and this is what I am showing here. So this, I have enlarged this thing into this kind of situation. And if I allow several instructions, it will get executed. What the print function does is it simply displays the content inside this argument, inside this parenthesis, right? And after it is over, you can see the control goes back. So this arrow here shows that the control goes back to the main program, right? And earlier we saw the control pass to subprogram, and once it's get executed, control goes back. So there will be a explicit return statement or maybe implicit return. And once the control comes back here, it continues the execution. Right? So calling a subprogram basically changes the control flow in that manner. Okay. And what is the use of, what about the uses of the selection control structure that we saw earlier? This selection, we know the usefulness of sequence, one after the other. We can carry out a set of tasks, right? So that is the usefulness of sequence. Here, the usefulness is that basically, we may want to change this sequential flow and decide this, do this or that, depending on the situation. So for that, this is useful, right? Note that we are actually going forward here. We are not going back. If you go back only, it becomes a loop, right? In the simple selection thing, you simply go back, right? Otherwise, you can see this decision point is there for the selection structure as well as for the loop structure. Loop also has checking, condition checking, but that actually is used for to decide whether to go forward, not in both cases to go forward, yes or no. If the condition is yes, is this equal to this one structure, you are deciding to continue, go back and continue things, right? So you can imagine the usefulness of this structure. It's basically, there are many situations where you want to keep doing the thing repeatedly. Maybe if you have a set of data, you want to repeatedly do the same thing on that data, right? If you want to process some data with respect to the students in a class, you want to do the same thing for each student, one after the other. So looping is a very fundamental, very important thing in computing. So this is useful for that kind of a thing. In that respect, what is the usefulness of subprogram? What is the usefulness? So as I was explaining, maybe you can have, something that's maybe very complicated set of things can be separated and implemented separately, and we can just, without worrying about how it is done, you simply call that and get it done. So that's a kind of implementation thing. Right? In your algorithms or in your flowcharts also, you can indicate. Of course, in the flowcharts, that's a special symbol, right? As we have seen, without actually showing the calling to subprogram, returning from that, you can actually indicate the separate task in this kind of manner, right? So that is like, okay, this is a complicated something which is implemented separately and explained elsewhere. Here we just indicate it is a task, some set of tasks, and then you continue. It's basically like putting the whole thing inside something, right? Like this. Okay. So, but other than that, so then what exactly is the real use of the need of the subprogram? Okay, let me ask it another way. Now the sequence control structure, is it essential to express a particular algorithm? I mean, any arbitrary, if you take any arbitrary algorithm, you think the sequence is really essential? Without sequence structure like this, will we be able to develop any algorithm, any arbitrary one? Answer is no. Actually, a sequence is an essential one. Without that, we won't be able to write certain things. I mean, of course, somebody can say we can put all these things into one block and indicate, but I mean, if you want to go statement by statement, you need this, right? Therefore, this is a must. And what about the selection? If you do we really need it? Is it essential generically to express any arbitrary algorithm? Which in other words means, do we really have to have this? Without selection, is there some computation that we cannot carry out? Yes, indeed. Actually, this is essential. This is a structure that is without which we will not be able to write certain algorithms. Because we want to make this condition or selection, select this or that. That is a generic requirement. So therefore, this is essential. Okay. And what about the loop? Is this essential? Again, for any arbitrary kind of algorithm, any computation, do we need the looping? Can't we do it without looping? No, you cannot. So loop is a must. We need this also in order to do any arbitrary and talk about some computation. We will need it. Of course, there can be some examples. One very specific one you would have seen in our previous lecture, in lecture number 1, when we talked about the simple algorithm descriptions. There was one example where the computation of the circumference and the area of a circle, we didn't have the selection, we didn't have loop, but that's also a very special case. What we are saying is generically any computation, when you take any computation, can we do it without using a looping? The answer is no. Therefore, if you identify these control structures, this is an essential structure for writing algorithms, for describing any computation, basically. With that kind of understanding, we know that the selection, right? We know that the selection, then, sorry, that is the second one. First is the sequence. Second is the selection. Third one is loop or the repetition. And we must have selection, sequence, we must have selection, we must have loop, right? To do any generic computation. In that respect, what about the subprogram? Can we do something without actually a subprogram structure? What do you think? Is this essential for any generic computation? So the answer is actually yes. So this is not essential. What I mean is, if you have an algorithm that uses a subprogram, or if you have a program that uses a function or a program, you can of course come up with an algorithm which doesn't use one. We can have an equivalent one for the same computation. We can write an algorithm without using a subprogram, because if we have sequence, selection, and looping, that's enough for us. So these are the fundamental things. Sequence, selection, and loop are the fundamental things that are needed for a computation, right? This subprogram is actually a useful thing, definitely very, very useful. You can say when it comes to developing software, developing programs, because you can actually make, say, let's say, you can make into a subprogram any unit of work, any particular specific task into a subprogram if they are frequently needed, and then you can call it whenever you need. That is what we do indeed, when you want to print, right, you just say, you call the print function whenever you need the print. And you can actually divide your work and get the team members to implement each task by a function or sub-program that each person can develop. And so this is basically the modular development. So just like a modular, if you want to construct something, you divide the whole construction into several modules, and then you can independently, separately build these things and put them together. So software development, program development can be done this way by the modular development is supported. Modular development is a fundamental thing that humans are capable of, right? From the historically, people have been developing, building things in this manner because it's a nice, structured, and a good way to divide the work and make it more manageable, right? So the basic thing the subprogram structure provides is this modular development. Which also, especially unlike in some other development, like let's say construction where real things are constructed, in the case of software development, you can use this fact that, okay, if you have a subprogram which is generic, it supports some generic function, generic activity, generic task, you can call it whenever you need it. And so if you have a particular program, let's say you don't have the print, right? So whenever you need to print, you will have to write your own code, right? And you need to get it executed by writing the code that what the print is doing has to be written by you. And if there are 5 places that you need to do printing, you have to repeat the same thing in those 5 places in your code, right? Now, if you have the print, what you can do is in each of those 5 locations in your code, you can simply call the print, right? And what does that mean? Your program will get shorter as well, right? Easy to read and easy to understand as well. So the modular development has all these advantages. But fundamentally speaking, we know now that the subprogram doesn't actually add any special capability which the other 3 cannot do, right? Sequence, selection, and repetition together actually provides all the functionality we need to do any generic computation, right? We can do without subprogram. Subprogram provides some additional advantages, benefits, which are again very, very important, but fundamentally it doesn't add anything that other 3 cannot do, right? So I hope that's very clear. Of course, for programs, this is very important. The functions for subprograms, and we will cover functions in in Python in a later lecture. And okay, so that's basically the end of part 1.